All right, let's dive in. Today, we're talking about how two incredibly powerful technologies are completely rewiring the high-stakes world of energy. We're talking about the Internet of Things and edge computing. And look, they're not just changing the game, they're building a whole new one. And it all starts with a single, pretty shocking number.
So let's just start with this number, $20 million. That is the insane cost of a single day of unplanned downtime for a big energy operator. Just one piece of equipment fails, and the financial bleeding starts right then and there. But the real shocker isn't even the number itself.
It's the fact that this kind of catastrophic failure happens, on average, 5 times a year for just one operator. So you gotta understand, this isn't some hypothetical what-if risk. This is the routine, budget-destroying reality of their world. And it proves that the old way of doing things, it's just completely unsustainable.
And that really brings us to the core of the issue here, what we're calling energy's trillion-dollar problem. It's all rooted in a model that is, by its very nature, reactive. You see, for decades, the entire industry has been running on this break-fix model. You literally wait for something to go wrong, and then you scramble to fix it. Sure, you've got your periodic manual inspections and scheduled maintenance, but in today's world of aging infrastructure and crazy demand swings, it's just not good enough anymore. It's kind of like trying to drive down a highway by only looking in your rearview mirror.
So how do you actually get ahead of a problem like that? Well, you give the entire energy grid a digital nervous system and a set of instantaneous reflexes. And this is exactly where these two game-changing technologies come into the picture. Honestly, thinking about it like a nervous system is the absolute perfect way to get it. The Internet of Things, or IoT, that's your digital nervous system. It's thousands of sensors bolted onto every critical asset, pumps, turbines, you name it, constantly feeling for the tiniest changes in vibration, temperature, and pressure. But hey, what good is sensing a problem if you can't react in time? That's where edge computing comes in. It's the reflex. It processes all that data right there at the source, which allows for an automated millisecond response that can prevent a failure before it even has a chance to happen.
And look, this is not some little niche experiment. The market is pouring unbelievable amounts of money into this shift. We are looking at a jump from about $85 billion this year to over $700 billion in the next decade. What this tells you is that this isn't just about chasing a trend. It's a massive, strategic bet on a much more resilient and efficient future.
Okay, so the money is flowing in, but what does this massive investment actually deliver? I mean, market projections are one thing, but the real-world results, that's where the story gets really compelling.
I mean, check out these numbers from the U.S. Department of Energy. These are the kinds of stats that make executives in a boardroom actually sit up and pay attention. We're talking about maintenance costs dropping by nearly a third, asset breakdowns just plummeting by 75%, and that crippling unplanned downtime getting cut by almost half.
Let's put a real story to these numbers. Take this case study from NextEra Energy. Their system picked up on this tiny, subtle change in a vibration signature on a gas turbine. It was an almost imperceptible signal that a bearing was about to fail. This super early warning let them schedule a repair during an already planned outage, completely avoiding what would have been a 2-week emergency shutdown. And the price tag for that one single shutdown they avoided? A cool $3.2 million in lost revenue. That's the power of moving from being reactive to being predictive. You're not just saving money on repair costs, you're preserving millions in operational income.
Now, you're probably thinking, okay, this kind of tech must take years and years to pay for itself. But actually, the data shows the complete opposite. For targeted pilot projects on the most critical assets, companies are seeing a positive return on their investment in just 9 to 12 months. This technology pays for itself, and it does it really, really fast.
But of course, if it were that easy, everybody would have done it already. While the rewards are absolutely massive, the path to getting there is filled with some pretty significant challenges.
So yeah, if this stuff is so powerful, what's stopping every single company from jumping in with both feet? What are the big roadblocks that leaders have to navigate?
Well, there are really 5 big ones. First, you've got to integrate all this new tech with decades-old brownfield systems. That's just the industry term for existing, sometimes ancient infrastructure. Second, connecting equipment that was never meant to be online suddenly creates a massive new target for cyber attacks. Then, of course, there's the high upfront investment, complex data security rules, and finally, a huge cultural gap between the IT teams, the folks who live in the world of data and servers, and the OT, or operational technology teams who are actually managing the physical machinery out on the ground. So, to get past these roadblocks, you can't just throw more hardware at the problem. It actually requires a fundamental shift in thinking. The solution has to be built on a whole new architectural philosophy, one that's flexible, secure, and scalable right from the start.
And this new way of thinking is actually borrowed from the world of modern software. The idea is pretty simple, really. First, you package up your analytics tools into these universal, self-contained boxes that can run pretty much anywhere. Then, you use an automated system to manage and deploy these boxes wherever they're needed, whether that's a central server or a tiny sensor on a remote pipeline. And the result is that you're no longer building some rigid one-off solution, you're creating a flexible, secure platform that can adapt to whatever the future throws at it.
So where is all of this heading? Well, the ultimate goal isn't just to predict the future. It's to create systems that can act on it all by themselves. Today we're all focused on predicting failures, but in the very near future, we're going to see this hyper-convergence of AI, 5G, and digital twins, which are basically virtual replicas of physical assets. But by 2025 and beyond, the whole game shifts to fully autonomous operations. We're talking systems that can self-heal, self-optimize, and make decisions without a human ever having to intervene. And if there's one stat that really drives home just how massive this shift is, it's this one from Gartner. By next year, a staggering 75% of all enterprise data is going to be processed out at the edge, right where it's created. I mean, that's up from just 10% back in 2018. The reflex is becoming way more important than the central brain. You know, what's really fascinating is that what's happening in energy right now is basically a blueprint for other critical industries. The challenge of managing these distributed, mission-critical physical assets is the exact same one faced in healthcare, finance, manufacturing, logistics, you name it. The same predictive models preventing a turbine failure can be adapted to predict an MRI machine failure, or even detect financial fraud in real time. This really isn't just an energy story. It's a story about the dawn of a new, intelligent, industrial era. The platforms and the patterns being perfected on oil rigs and in power grids today are going to redefine efficiency and resilience everywhere tomorrow, which it just leaves us with one final thought. When is this transformation going to rewire your world?